Okay, hi everyone. This is Ehab. Today we are talking about primitive data. In primitive data, we are talking about numbers. We are talking about characters, Boolean expression, Boolean data types. And today's agenda, we are going to talk about output streams, input streams, variables, numbers and operators, precedence, and characters. Before you start this lecture, before you continue with this video, start up the Visual Studio 2019 and create a local project and call it Sandbox 2. So I created my Sandbox 2 already. So, you know that programs are made up of two main components: the data, which is the numbers we talked about, characters, anything you want to store, and the actions are going to be the functions we are going to use in order for us to manage this data. When I say manage, for example, if I have int x equal 5. Now this 5 is the data, and it's being stored in a variable called x. Now, an action could be a function that would store that x and change it to be, for example, 7. Now, this function is going to be used later. We are going to take that in lecture 5. Don't bother with function right now. So, data could be characters, the strings. Strings are kind of words. Anything in double quotations. Like it could be a word like hello, as long as it's in double quotations. And it could be also 1, as long as it's in double quotations. This is 1. Anything in double quotations. And characters are going to be only single characters, like alphabets, digits, as long as they are in a single quotation, even the 1. Or it could be H in a single quotation. Data could be also Boolean. A Boolean is going to be either true or false. Now, we use Boolean in order for us to store the result of a Boolean expression. A Boolean expression is like, is x greater than 3? And numbers, numbers 1, 2, 3, and could be positive numbers or negative numbers. Numbers are whole numbers like 1, 2, 3, or floating point numbers like 2.5, 2.3, or negative 2.5, 2.1, and so on. For the actions, we have functions, as I said. We have keywords. Keywords could be like the if statement, if and while, int for the integer. Operators like the plus, minus, greater than, less than, insertion operator, and so on. So here's some examples of the data, and here's another set of examples of functions, keywords, and operators. So what we are aiming for in this coder is to be able to create an object-oriented programs, object-oriented based programs. So the object-oriented programming is bringing those two, the data and the actions, together to create an object. An object is going to be formed by the class, and this is something we are going to discuss in lecture 9. So we just said we have primitive data, and we are going to discuss the primitive data, but we have something. Object-oriented programming is creating another kind of data types, which is the non-primitive. A string, for example, is a class. It's not like the int. int is a primitive data type. However, a string is not. And we are going to see the differences throughout the code when we start with the using primitive data type and the string class from the non-primitive data type. And in lecture 9, we are going to start creating our own data type, a data type like a student. And if your name is John, we are going to create a data type called John, whatever your name is. So let us just use the strings. So we have a string greeting, hello world. When we print, and by saying print, I use cout. Cout is sending information from the code, your code, to the console, to something like that. Here is, we are sending the information stored in the variable greeting to the cout in here. And we can also use certain functions like length, and this length is accessing the greeting variable and counting the number of characters. So if you're going to try that, let's go to the greeting, copy that code, and we are going to paste that in our IDE in the Visual Studio. Now, as you can see, this is not recognized. The cout is not recognized. What's missing is the statement when we say, okay, we are using a namespace called std, which is the abbreviation of the standard libraries. Now, you have to use that line, you have to have it in your program if you have been using anything from the standard libraries. Like cout, we did not create a cout. This is a keyword in the standard libraries, or basically it's a variable used in the standard libraries. In order for our compiler to recognize this, you have to include this statement. And we can run it without any problems right now. This is going to print hello world and print the number of alphabets. And you can see here we have, in hello we have 5 characters, in world we have 5 characters. But don't forget that the space in here is also counted as a character. Now you can close that using by pressing any key or clicking on the X. One more thing, if you're using strings, because we are using Visual Studio 2019, it doesn't matter that much. But in some cases, especially if you have a big code involving some mix of C and C++ libraries, I recommend that you always include string if you are using strings. If you're going to define any variable of the type string, always include the strings. This way you don't face a lot of problems. Like, you get rid of a lot of problems regarding strings and creating strings. Okay, let me just make sure that this is recording, and yes, we are. Okay, so why do we use cout? We use cout to send information to the screen. The screen is the little window that popped up when we clicked on run, the black window. So basically we can say that cout is sending information to the screen. Okay, what is cout? Okay, cout is abbreviation of character output. So let me ask you something. What is a data stream? The data stream is like any other stream, but we are sending the data. So the flow is the data. So define a stream. A stream is a flow of a matter, something. A flow of something. And usually it's unidirection, like it's going from one direction, one point to another. In C++ or pretty much in all programming languages, we have something called data stream. In this data stream, we have data flowing, and based on what we use, whether we use cout, and the out is outputting, or cin, outputting characters or inputting characters. Cout, when we send something, here is our data stream. Here is our data stream. If we are sending from the program to the console, then we are using cout. If we are sending on the opposite way, we are sending from the console, the keyboard, to the program to store it in a variable in our source code, then we are using cin. Okay, so cout is a data stream that goes from your program to the screen. That's good. We use the insertion operator with the cout. The insertion operator is putting something into the string. Like if we have this string, this is a string. Remember that a string is anything enclosed in a double quotation. Now, if we have this string, if we want to send that out to the output console, then we use cout and we use insertion operator. Cout is our output stream, and the insertion operator is the operator that puts the string into the console. Okay, here is some things we are going to see. Here are some examples. We have cout data 1, cout data 2. What do you think will be displayed on this screen? Data 1 space data 2, because we sent them in a separate statements, or data 1, data 2 separated by a new line, or these are going to be attached to each other. I'll give you like 3 seconds to think. Okay, the answer is data 1, data 2 attached to each other. The two commands above in here, they're actually add a string to each of them, add a string to the output stream. Now, neither of them is including any space. If we want to include spaces, for having a space in between them and between of those two, we add a space either in here or in here. If you want them separated, you can do that like by adding a slash n. This is a backslash, not forward slash. A backslash n after the data 1 word, and data or before data 2. Or you can do that like this: cout data 1 end line. This is E. Anyway, it's not drawing the E. And this is end line. Okay. Some pen malfunction. Anyway. So these are all these commands, all these cout data 1, then data 2. And you can see whenever we want to insert something different, we are inserting that with the insertion operator. We say, okay, insert this into the cout, then insert this into the cout using an extra insertion operator. If you want them attached also, you can attach them in one word as one word. You can have them both in separate lines, but they're actually one statement, because how do we end a statement in C++? By having a semicolon. Like if we are going to have a semicolon in here, then this is going to produce an error. Why? Because this statement printed data 1, but this statement is not putting into anything, so this is an error. These are two separate statements, which is good. Okay. Cout also works with different kinds of data. Cout is a smart variable, and it can handle a lot of data types. Like you can send a string, you can send a character, and you can send a number. And Cout is going to receive all of them, and it's going to handle each of them correctly without your involvement. So the output is going to be hello and then A42. Why there is no spaces? Because we haven't added one. So here's something. Cout is going to print this as a string as it is, and again, if anything is enclosed with double quotations, it's going to be printed as it is. It's not going to say, okay, we are going to add a 5 and a 4. No. But if something is not enclosed in double quotations, like this, it's going to be calculated. So this goes the way it is, 5 plus 4 equal, including the spaces. We have a space in here, a space in here, and a space in here, and in here. So then 5 plus 4 is going to be calculated, then printed as 9. And this is the breakdown of how it actually works. So we have something called string letters. String letters is anything enclosed with the double quotations. It could be 0 character, like this one, without a space in here. No space in here. This is 0 characters, and this isn't considered a string. Or it could be more than 1 character, including the spaces. When a string letter is sent to the Cout, it will display all the characters which they are inside the double quotations. And look at this, just as they are shown. Like when I have hello words including a space, it's going to be hello word including a space in the output on the console. And this is true most of the time. Why do we say most of the time? Because if we took something like that, something like Cout, he said hello there, and we paste it to the Visual Studio. Let's see what's going to happen. Let me go bring that. It's going to be in here. Okay. Let's get rid of this, and we do. He said, okay, we see that there's a problem. Let me just try run it, maybe it will go away. And it's not going away. Why? Because, look, it says that user-defined letter operator not found. And it says, okay, expected a semicolon. Why is that? So we have a Cout, which is, okay, it's being recognized because we have the std. Okay, that's good. Then insertion operator. Then the insertion operator is followed by a string. But then you don't have a variable called hello. Now the compiler is considering this as a variable. If you define, for example, if I'd say, okay, string equal hello, Oh, sorry. A string hello equal ABC, and then this is going to say, okay, I still don't recognize hello. But if I start, remember that is when I said whenever you are inserting something into the CR, you have to use the insertion operator. Now that says, okay, I recognize hello, but I don't recognize there. Okay, but this is not what we wanted. Okay, let's go back to make it the way it was before. Control Z. And I want to see the double quotation on the console. I want to print that. Then we have to treat it in a special way. How do we treat certain things in a special way? And again, those are things that should be recognized by the compiler. It's not something you say, okay, I decided to treat the letter E in a special way, so I'm going to add the backslash. No, it's not up to you. It's up to the creator of the C++ programming to say what's being created in a special way. Okay, I want to treat this in a special way, and this one. Now, okay, try run this. We should see the double quotation printed. Okay, we see that right now. That's good. Okay, going back to our presentation. So, that was a compilation error because the double quotation is used to mark the beginning and the end of the string letters. This is the beginning, and now this is considered the end of the string letter. And these are variables, but they are not recognized by the compiler. And here is the fix of showing the double quotations on the screen. We have some other things we use with the escape character. We call that escape character. And the escape character is telling the compiler to treat the next character, the following character, in a special way. For example, if we have an escape character followed by N, this is telling the compiler, okay, add a new line. Let's try that. Here is something. I'm going to show you the effect of the new line. Okay, if I do that, I don't have a new line. Do you want to add a new line? Okay, \n. Now see the difference? We have a new line in here. Okay, if we want to see the effect of \t, which is adding a tab characters, which is few spaces, 4 to 6 spaces, depending on your encoding. Let me have, he said hi. So we should have a gap worth 4 to 6 spaces, depending on your encoding. So this is going to show you the tab. Okay, let's try that again. And this should see, okay, here is this. So in my machine, I have it as you can see, 8 characters, not 6. Also, we can try having the sound. Listen to the sound. This is a bell sound. Okay, this is the sound that comes out when we use the \8. Okay, you can, if you want to display the double quotations, this is what we just did in he said example. You can use double quotations if you want to display the single quotation, \single quotation. If you want to display the backslash itself, you can, because remember the backslash in C++, generally if it's inside the string, it says, okay, treat the next or the following character in a special way. This is saying, the first one is saying treat the next character in a special way. This one says, okay, I'm being displayed. So display the backslash. And you just heard the build sound in the machine. Okay, let's talk a little bit about input streams too. So remember, input streams is like output streams, but instead of having the code sending to the console, now we are getting something from the console and store it in a variable in our code. So, for example, the cin is taking something I write on the keyboard and inserting that into a variable. So I define a variable in here. I call it num. It's of type int, and cin is going to take anything I write on the keyboard and store it in num. Okay, let's try this code and I will show you the effect of having that. So if I just copied that and I take it to the Visual Studio, let me run it. That should first display enter a number, and I have to enter numbers. For example, I entered 23. I have to press enter because enter is going to give the compiler a signal that I'm done inputting, I'm done typing. Okay, that stored the 23, this 23, into num, and then we printed what we stored. Your number is the number I stored. Okay, your number is 23. Okay, let's go back in here. So the cin is not using the insertion operator. Remember, the insertion operator is you insert something from your code to the console. The cin, however, is using the extraction operator. The extraction operator is extracting something from the data stream. Here is the data stream. Whatever you type is floating in here, A, B, C. This is extracting what you have and store it in num. Extracting from the data stream to the variable you extract into. Here's an activity you should try. Now, you should take this code. Here's the code. You should take this code and copy that into your Visual Studio. Now, here it is. Oh, I was doing this. Okay. Let me just copy the whole thing in here. I'll replace all the code I have. Okay, now I have a good code. Int num1, num2, cin num1, cin num2. So I'm taking two inputs from the user and store them in num1 and in num2. And after that, I'm going to print what I just stored in num1 and num2. Let's try this. So the first example we are going to try is when I store, and when you see that starting to blink, and this is showing here that everything is ready for you to enter your input. So, okay, I'm printing 1, 2, 3, 4 in num1, and then 3, 2, 1 in num2. Okay, everything is perfect. 1, 2, 3, 4 in num1 and 3, 2, 1 in num2. Let me just try and rerun it to try different inputs. So I'm waiting for that to be ready. Okay, now it's ready. The first input, I'm going to have 3, then a space, and 4. What do you think will happen? Is that going to be stored all in num1 because I haven't pressed enter yet? Or what? I'm going to press enter. And 3 is being stored in num1, and 4 is being stored in num2. Why is that? Because the space is working as interrupting signal, interrupting the inputting to num1, and the compiler is taking the other input, the 4, into num2. Okay, let's start doing something. And I will start inputting a space. Here's some spaces. Then a tab. Here's a tab. And then 3 and then enter. Oh, still asking me for inputs? What is that? Let's enter 56, then enter. So 3 is going to be entered in num1. 56 is going to be entered in num2. Now, why is that? Because the compiler in C++ is ignoring any white spaces ahead of alphabets and any other characters. So the space, or in general, something we call white space, is being ignored. If it's being inserted as the first thing, like what we have done in here before any digit or any alphabet or any special character, it's going to be ignored. If it's inserted after the characters, the special characters or digits, it's going to be considered interrupting signal. I hope that is easy and not as confusing as it seems to be. So you try different inputs and see yourself what is going on. So the notes, the conclusion after you try these inputs is that if you try the extraction operator, will consume or eat white space. Will consume or eat a white space. The white space is a space, a new line, and a tab. Those three things are considered white spaces. We tried that with a tab, then enter, then 3 space 4. 3 is being inserted into num1. 4 is being stored in num2. The second note is that the extraction operator will read as much as legally possible. Now, why do we say legally possible? Because I'm going to try something. Okay, let's try this. You know, the int is going to take up to 2 to the power 31 minus 1. 31 minus 1. So it's going to take up to 2 billion and something. So let me just try doing this. Now, if I press enter, this is going to store the maximum value that could be stored in an integer, in num1, and a garbage value, something we call a garbage value. A garbage value is a value that we don't recognize. It's arbitrary value entered by the compiler. So this is something going to happen if you don't enter something legal, which is from negative. Let me just write it on here. Legal, if you're dealing with integer, it's going to be from 2 raised to the power n. And for the integer, n is being 32 bits. So n minus 1 to 2, where is the 1 going? Okay, 2 raised to the n minus 1 minus 1. And we are going to see that in one slide, what that value is. So if you give, the third note is, if you give the wrong data to the Cn, it's being corrupted. Corrupted means that it's going to skip all the extractions, all the reads. Let me try something. Let me corrupt the data, intentionally corrupt the data. What is I'm expecting? I'm expecting an integer. and I'm going to print an alphabet. Alphabet is going to store 0 in num1 because it's corrupted, and it's going to skip all other inputs. Skipping other inputs is going to store garbage values in those inputs. So num1, because it's corrupted, it's going to receive a 0, and num2, it's being skipped, so it's going to receive a garbage value. Also, let me try something. If you do 3.6. So 3 is going to be stored in num1, and the dot is corrupting the data because I'm expecting an integer, but the dot is a character, right? It's being considered a character. So this is corrupting the second input. It's corrupting the first input, which is going to stop at 3 and take it. Num1 is going to be 3. Num2, however, is going to be 0 because num2 is the corrupted input. Now, the dot acted as two things. One, interrupting signal. 2, corrupting signal. Interrupting signal, okay, take the 3 and stop. Corrupting signal, corrupting the num2 value, which is going to be receiving a 0 instead. You just have a sip of water. Okay, going back to our slides. So, from the rules we learned, what will you get if you have the following sequence of statements? Int I, double D, string S. Now you know that int is taking whole numbers, 1, 2, 3, -1, -2, -3. Double is going to be taking floating numbers like real numbers. Those are having fractions, like we have the dot involved in double data type. Strings is basically anything enclosed in double quotations. So if I have this sequence, CNIDS, take it, try it, then come back to continue the video. So CNI, I'm going to enter this. I'm going to enter without a stop. Like I'm going to enter 25.34J345. Then enter. What is the output? Now the output would be I receiving 25, D double receiving 0.34, then J is receiving 345. Let's break down this input. Now this input is having the 25 in the I, and we are still receiving, but wait a second, we have the dot, which is going to corrupt. The dot is going to corrupt the input of I. So we continue with the second one. Now we started to put things into D. Now D is double, and you know with the double it's allowed to enter the dot. Now we have 0, then the dot, 3, 4. Then we have J. The J is again acting as first interrupting signal, interrupting the input of the double, of the 0.34. And then it's going to corrupt the next input because it's expecting integer, double, sorry. But wait a second. What is the next input? The next input is a string, so I can't put anything in there. This is why it's being like this. Now, let's try something else. Let's rearrange the inputs. Now, rearranging the inputs is going to be something like that. Let me just go there and copy this so we can try it. Let's try this. So we are trying this. Let's remove this, paste that, and now we are going to enter in here. And remember, we are storing the first thing in the string is. Let me try the input. The input is 25.34J345. And here's an enter. But still waiting for things. Because the enter actually said, okay, we finished entering things into the string. But the compiler is still waiting for the I and D. Okay, for the I, here's 12. Then D is 34.6. Okay, we're good. We are good. But remember, the arrangement of your variables matter a lot. Okay, we tried that, and here is a screenshot of what I tried before. Okay, the CN notes again. It consumes, eats the white space, and operator, the extraction operator will read as much as legally possible into the variable. If given the wrong data, the input stream will be corrupted. Now, this is going to be either in a quiz or the midterm, or both. Okay, so these three blocks, this block, and this block, and this block, those three blocks are doing exactly the same things, asking for two inputs to be stored in num1 and num2. Okay, let's talk about the main number data types, the integer and the floating point. Now, the integer is the default for whole numbers, and the floating point default is double. Does it make it as if we don't have anything but integers and doubles? No, we have a lot, depending on the size of the variable we want. Like we have byte. This is storing up to 8 bits. So numbers ranging from negative to the power number of bits -1, so 7, to positive 2 to the power 7 -1. This is a byte. Then we have the next is short. And this is 16 bits. And we have then the integer. The integer, you know, is 32 bits. Then we have long. This is 64. Now these are the main whole numbers data types. With the floating point, we have float and we have double. We have double. The float and the double, we are going to see the difference between both float and double, because it's a significant. One takes up to 7 digits of precision. The other is taking up to 15 digits of precision. Okay, so talking about integers, we have the int data type. The int data type is going to have either 16 bits or 32 bits. Why did I say always 32 bits? 32 bits. I haven't mentioned 16 bits before now, because 16 bits is used in the older machine and compilers, which is like, we can say no one is using them anymore, or not many people using them anymore. The modern machines and compilers, they all consider the integer 32 bits. And this is how you get the numbers. If I know that I have 32 bits, you know the formula right now. From the range is from -2 raised to the to n minus 1 to positive n minus 1 minus 1. 2 raised to the n minus 1 minus 1. This is how you get n is being the number of bits. Okay, now how do we get the maximum of each data type? Simply, you can go to your Visual Studio and copy this. This will give you the maximum of the integer. Now, in order for you to use this, you have to include the library climits. Now, I'm going to show you how, and I'm going to give you something that you haven't seen if you haven't used Visual Studio 2019 before that. So we first include the climits, and then we print cout, and we are going to use all caps int, and as you can see, it says int 16 max or int 16 min, or the usual int underscore max. I always like to enter a new line with end line. So let me just run this, and this should print the maximum number of the maximum value of an int. As you can see, if you did that on a calculator, you should get that 2 raised to 32 minus 1, which is 2 raised to 31 minus 1. And this is the range we have in here, right? And this is the range that we can get from this slide, the one we said, okay, here is the maximum. Okay, the trick I was talking about is that what if in 2019, in Visual Studio 2019, I haven't included the climits? Is that going to still give me the maximum value I can store in an integer? And the answer to that is yes. You still got it. In 2017 and 2015 versions, you won't. So going back in here. So what I want you is to try this code in your Visual Studio and see what values are printed. Now the values are going to be the following: the maximum of an integer, then the minimum, then the maximum again. How so? I'm actually incrementing, I'm storing int max into the num, but then I'm incrementing. Now there is a rule, and this rule is going to be in the exam, that says if you increment beyond the maximum value, the minimum value is going to be stored in your variable. If you decrement beyond the minimum value, the maximum value is being stored in your variable. Let's see that. Okay, we incremented beyond The maximum value we incremented by 1, which is overflow. And as you can see in here, that gives you the negative number. And now you have the negative number. Remember the negative minimum. When you decrement by 1, it's going to give you the maximum. This is going to wrap around to the other extreme. And this is a rule you should memorize. Okay, let's play with numbers, with math operations. Okay, math operations, we have the plus, the negative, addition, subtraction, and we have multiplication and division. When you try those are going to give you 9, 1, 20, and 1. 9 for them, 5 plus 4, 1, 5 minus 4, 5 times 4 equal 20, 5 divided by 4 equal 1. Oh, wait a second. 5 divided by 4 is not 1. It should be 1.25. But instead I get 1. Why so? Because we have a rule. Always memorize this rule. Int divided by int gives you int. Okay, let me give you an example. 5 divided by 4. 5 divided by 4 equal 1.25. What's going on? I'm going to take the whole number part of it. Remember that int represents whole numbers? So we take the whole number part of it, which is the 1, and store it, or print it, if I'm printing. So this is why we have 1. Int divided by int gives you an int, the whole number part of it. Okay, what if we have this? 5 divided by 4.0. Now, the default, the compiler is going to investigate this. Okay, here is one number. This is 5. This is a whole number. So I'm going to store it in a temp variable of type int internally. Then I'm going to store this. This is floating point number, and the default is double. Let's say it's storing that in a double type variable internally, and then doing the division. Int divided by double. This gives you double. Now, wait a second. Does it have to be at the bottom? Can I have it in here? Yes. Also double divided by int gives you double. So, if double is involved, or a floating point, it's not only double, it's also with a float. If a floating point number is involved in the operation, then the output is going to be a floating point number. Now, we have something called the mod operator, the modulus. The modulus operator is going to give you the remainder. So 6 divided by 4 gives you 1. Remember, that is 1.5, but we get only the whole number part of it. Now, 6 mod 4, what is left after you have the division? 2, because 6 divided by 4 is going to give you 1, and we have 2 as a remainder. How do we get the remainder? With the modulus. Okay, how the modulus is being calculated? How do I know it's 2? The compiler is actually going to do that. Going to do 6 divided by 4, which is going to be 1.5. Then the compiler takes only the fraction part, which is the 0.5, 5 times the denominator. The denominator is going to be 4, and that is going to equal the 2. Here is your remainder. I explained that in here. You're going to be finding that in your slides. Okay, so let's do that. See out 5 mod 3. What is 5 mod 3? Okay, you guessed it right. 2. What is 3 mod 6? 3. Why is that? Because 3 divided by 6 is 0. What do I have as a remainder? 3. 10 mod 6 is going to be, the division is 1, and the remainder is 4. And the modulus is asking you for the remainder, so the result is 4. 98 mod 2. Let me ask you something. What is 98 divided by 2? It's a 0. Basically, it's the 49. 49. Do we have a remainder? No, because it's even. Any even number divided by 2 gives you a remainder of 0. So 2, 3, 4, and 0. Okay, so from the modulus, if I have x, let x be any positive number. Any positive number. X mod 1, this should give you 0. X mod 2, this gives you either 0 or 1. X mod 3, this gives you either 0, 1, or 2. Now, as a rule, if I have x and n are positive numbers, x mod n gives you any number in the range 0 to n minus 1. N minus 1. Simply because if x is equal to n, like x equal n equals 3, then 3 mod 3, that gives you 0, right? 0. Okay, so if you have n positive number, x positive number, this is going to always give you 0 to n minus 1. If they are equal, that gives you 0. If they are not equal, this gives you anything but in the range 1 to n minus 1. Okay, so what is the output of this statement? Let's work like math. First thing you do in math is looking for parentheses, which we don't have, but then you look for the multiplication or the division. Oh, we have multiplication. We do it first. So 6 times 3, this is going to be 18. Plus 4, and we have 10 minus 18 plus 4. So the plus and the minus, they are equal in precedence. So we have this 10 minus 18 plus 4. 10 minus 18 is going to be negative 8 plus 4. Then negative 8 plus 4, that is going to be negative 4. And this is negative 4. If you want to force an operation to happen before its natural precedence, you put it inside parentheses. Like if this is plus, this is going to force this to be calculated before any of these two. Always the parentheses taking the first or the highest priority to be calculated. Then the multiplication, division, and modulus is going to be the next thing, and the plus minus is going to be the Next thing. Okay, what if we have this? We have 20 minus 4 divided by 5 times 2 plus 3 times 5 mod 4. Okay, let's always start with the parentheses, right? So this is going to be 5. And then we are going to start, we have division, we have multiplication, we have another modulus. And remember that those all are on the same level of precedence. So we start from left to right. So 4 divided by 5. You started to say 0.8. No, wrong. Int divided by int is int. So basically, if I say 4 divided by 5, this is 0.8 naturally in math, but in programming, I only take the int part, the whole number part, which is the 0. So this is 0. 0 times anything is 0. So the final result is going to be 20. Let me just prove to you that by copying this operation. Where is the operation? The operation is in here. Copying that operation and put it in the Visual Studio. Okay, remember that we said the whole side, this side is going to be 0. Okay, let's see. Oh, 20 minus 0 is 20. So yes, we were correct. This is 20. Okay, something also to think about. If I have a mathematical operation, I'm sending to the cout. Is the compiler going to calculate that? Yes, it is. Why? Because the plus and the multiplication takes higher precedence than the insertion operator. So the insertion operator is not going to be done first, but we are doing the whole calculation before we send the final result to the cout. So the insertion and extraction operators comes after the plus minus, at the very end of these 4. Now, the calculations are going to be sent first. Okay. Now, let's talk about variables. Why do we need variables? Let me just show you something. If we have a calculation like in here, cout 3 plus 4. Where's the result of 3 plus 4 goes? It goes to the console and then vanishes. Why? We don't want that to go away. We want to use the 7 later in our program. So we need a variable. A variable is a named memory location. A named memory location that we can store data of a certain type inside. So if I'm going to have this, how do I create a variable? I create a variable using 2 things. The data type and the variable name. I have to have the data type. So my data type is int, integer, which representing whole numbers. And I'm going to call my variable something. You have seen that in CS 110 or Engineering 121 if you're an engineering student. So you have seen that before. We create a variable name. Int number of students, for example. I have number of students. Then later I can say num students equal 13. I have 13 students. Now I stored my number of students in num students. Okay, how does that work? It works as the following. First, that reserves some memory. Goes to the memory and reserve it. Like if we have int num, this is going to be num pointing to the first available memory location in the stack, and it's going to name it as num. Associate the name with that memory. So basically it does not erase. When I say available, I don't mean it's going to be empty. It's not going to be empty. It has something inside. But now we control this location, this memory location. So if I try to use older compilers with just this statement, int num, defining a variable and then printing that variable, this is going to show me a garbage value. Remember the garbage value we just talked about? This is going to show me a garbage value. A garbage value. And in Visual Studio 2015, 2017, or 2019, this is going to give you an error. That is going to say, okay, you're trying to use something uninitialized. So you lack of initialization for this to be working. Here is the initialization part. If I have int num, then I say num equal 5. Num equal 5 is going to assign. Look at what I'm saying. Listen, I'm saying assign because the equal in here is not our math equal. No, it's assignment operator, which assigns something on the left hand side to the right hand side. So that stores 5 into num. When I print num, it's going to display 5. Simple. Now, if I do that, I say, okay, I created a variable, initialize it with 5. Now I'm printing num plus 3, and then printing num. What's going to be displayed on the screen? 8 and then 5. Oh, wait a second. So I added 3 to num. Now it's num. Now I think as num is 8. No, num is not 8. We retrieved the value from num. We added 3 to it. 3 to the value. And send it to the console. And that's the extent of it. So it's like I'm saying, okay, I'm retrieving the value from num, store it in temp of type int, and I'm saying this is 5. Then I'm saying, okay, 5 plus 3, send that to the console. But num is still 5. I haven't changed it. So if I'm doing that, that displays the 8. Oh no, this is not displaying the 8 because num is not initialized. It's displaying garbage value. And remember, this is if you're using old compilers. The new compilers are showing compilation error. Why compilation error? Because you used uninitialized variable. Now, in older compilers, that was taking whatever value we found when we created num, whatever value stored in that location, and added 3 to it. The new compilers are saying, no, wait a second, we don't recognize that value. So this is considered uninitialized because you haven't initialized that. Okay, now other ways to declare variables is, and by the way, creating or declaring is just having the variable name attached to the type or included with the type, but no actual value. The value is initialization. So creating two variables, I'm just creating two variables. I can store values inside later, but not now. If now they are uninitialized. So if I try to use any of them, it's going to throw you an error. So I can declare and initialize at the same time using this. Data type, variable name, the assignment operator, which is going to be used in the initialization process. Remember, the initialization process is assigning a value to the variable you just created. So assigning a value to the variable you just created. And this part is also called initialization. Now, this initialization is done without the assignment operator because this is going to be internally happening, the assignment part. Okay, so this is going to either initialize, going to give a value at creation time after it's being declared. This is declaring initialization. Declaring is just the creation of the variable without initialization. Okay, something useful. It's a good programming practice. Always initialize your variables because you don't want to get the uninitialized error. Remember that when you try to use uninitialized variable, it's going to throw you an error. It says uninitialized local variable. You don't want that. Okay, how do I name my variables? Now, if you're naming a variable, you usually start with a lowercase alphabet. And you must start with either letters or underscores. You cannot start with a digit, but you can have a digit, but not starting with one. Like you cannot have 1x or 1 hello. You cannot have both. You can, however, have x1, x2. That's okay because you started with a letter, or you can start with underscore, but usually you should not start with an underscore because this is going to have a special meaning. This is something in networks and reserved words. You don't have to worry about it right now. So names or identifiers, the names you just created, are case sensitive. Like when you have my object start with lowercase m and y, it's not going to be equal to this one. This is totally different variable. Like for example, if I have my x, y, z variable equal 3 of type int, and I try to do my x, y, z equal 4, then this is going to throw an error because this is not recognized. Remember that? Case sensitive. Okay. Variable names should describe their information. Like, for example, if I have a student ID, the good variable name is going to be student ID attached to each other, and whenever I start a new word, I capitalize the first letter. Or if it's abbreviation like ID, I capitalize all the letters of the abbreviation. Or I can separate them with underscore. You cannot separate that with a space. So student space ID is not going to work. because those are not space. You can never have a space in a variable. So a good good programming practice also is to use programming good variable names that describes the information. And by the way, while I'm grading your assignments, if I see that you named your variables x1, x2, x3, or v1, v2, v3, you get a 0 in your assignment. You should follow the appropriate standards. The standards is to name your variables with the good names. So do that. Also, if you're naming a variable, not a class name, which we are going to see in lecture 9, you should start with a lowercase. Now, this is usually used if you're naming a constant variable. We capitalize all letters, and if we have more than one word, we separate them with underscore. This is used to name classes. We are going to see that in lecture 9. Don't worry. So the assignment operator is not math operator. Again, I say that for 15 times. Now, if you try to do that, for example, int 2x equals 6, this is not going to store 3 in x, like saying, oh, it's going to be like math, x equal 3 eventually. No, it's not. This is going to give you an error because you cannot start your variable name with a 2. And the equal in math is not equal in C++. We call it the assignment operator. This is in math. In C++, it's called assignment operator. Assigning a value to the variable. Assigning a value from right side to the variable on the left side. Now, if we are doing this, int num, then num equal 5, then num equal 32 plus 1, then we print num. This is, firstly, that stores 5 into num. Then that stores 33 into num. That overwrites what's in num with the new value. So that is going to print 33. Now, if you do that, the result is going to be 5, right? Because you said, okay, int num equal 5, but then you overwritten the value in num with the value of 5. And that is going to be the same. But actually, this is two different operations. The first operation was declaring an initialization. The second was overriding something that is already defined. Okay, this is adding 1 to num. There is something I can use to prove to you that the equal sign we use in C++ is not equal. It's actually assignment operator. Using this, if I have int num equal 5. If you have num equal 5 and you have done this. Now in math, if you're talking about math, this is going to be num going to the other side as a negative. Num minus num equal 1, which is 0 equal 1. No, this should not exist. 0 will never equal 1, right? But actually in C++, that is being considered the following. Num is going to equal 5 the value of num 5 plus 1, which is 6. So num, the eventual num, is going to be 6, not 0 equal 1. So if we have this int num, then num equal 42, cout num plus 2, cout num, what will be displayed on the screen? Yes, 44, then 42. Why? Because this is adding 2 to the num, and then that vanishes. This is going to vanish. We printed 44 on the screen, then that vanishes. Okay, then num, we haven't modified num, so it's going to stay 42. If you want to modify num, this is going to do it. This is saying, okay, get the value of num, which is the 42. 42 plus 2, this is 44. Store that in num, which is I'm storing 44 still, then send the 44 to the cout. When I print the num, remember that we stored the 44 in num, that is storing 44 and 44. Okay. Now, the parentheses is going always to take the highest precedence. So, the parentheses comes first in the calculation, then anything else. Okay. That proves it, that this is 1, then this is 2, according to this table, right? Then this is 3, which is going to actually throw an error. Because you have to follow the precedence. You cannot have something like this. The last thing going to be executed must be to the left. So you should have 1, 2, 3. Not 1, 2, then 3. So, class exercise. Write a code that will ask the user for 2 integers, then give back the total of the 2 integers. Now, I suggest that you create a third integer and you store the result of the addition of the 2 into the third. You can do that, or you can just print the 2. And then print the average of the 2 integers. So here is a code that would do that. Here is a code that would do that. Now, first, I initialized 3 variables, num1, num2, and the total. Then cout, I printed a statement on the screen to the user, so the user knows that, okay, it's my turn to enter 2 inputs. I would enter 2 inputs. I would separate them with inner or a space for the first one to be stored in num1, the second to be stored in num2. Then total equal num1 plus num2. This is adding num1 and num2 and storing the result in total. Then I print the total and print the total divided by 2. Now wait a second. If you just took this code, let me just take this code. Where it is, it's in here. Let me take that to your Visual Studio. Okay, here's the, let me just close this. Here's the Visual Studio. Now, let me show you the effect, the actual effect. Let me just close this. The actual effect of adding 0.0. Since this is 2 integers, and the total is actually an integer, the division of integer to a double should result a double. Something with the decimal point. Let's just try that. Wait for that. Oh, wait a second. There is a problem. Okay, what is that from? It says that we are expecting something. Oh, I copied the whole. Okay. I'm going to replace the whole thing in here with that. Okay, now I have the correct things. include at the beginning, the using namespace at the second, then the main. Okay, that should work perfectly. So trying that, and the first number is 12, the second number is 13, this should be 25. Okay, now we have 25 and we have 12.5. Why? Because we added the dot. So the compiler is going to guess what is this type, and it's going to store it in a double, because the compiler is going to guess, okay, the default for something with the dot is a double. Let's remove that. Divided by 2. Or, you know, how we get the average? The total of the numbers divided by how many numbers? We have 2 numbers. So let's do that. 12 and 13. Now, 12 and 13, that gives you 12. Why? Remember the rule. If you have int divided by int, that equals int, resulting in an int. If you have a double involved, then that should be okay to give you a double or a floating point number. Okay, wait a second. Why do we say 2.0? Why don't we say total dot 0? Because you can never do that to a variable. There is a proper way to convert that convert that variable to a float. So let's try that. I'm going to spoil my next lecture by showing you that. So if this is 2, that was resulting only the 12. Now, how do I actually convert the total to a double? And this is on the fly converting. Static cast to what? To double or float. What I'm converting is the total. So that, even though that is 2, now we have that being converted to double. Divided by 2, this should give you the 12.5 you were looking for. Here's the 12.5. Press any key. That was good. Closing that window. Going back to our slides. Now, after this lecture, you're going to see on Canvas, this program. Converting number of days to years, months, weeks, and days. And you're going to see that in the first module or the second module. So you go to, here is your Canvas. Your modules are going to be those. You click on modules, and here is the lecture we were talking about, and here is your assignment number 1. Here is your assignment number 1. I'm going to have this assignment available for you with the accurate description inside. You open that assignment, you see the description, and I'm going to give you 7 days from the publishing of this assignment. So now you have the due date as April 22. It could be when I publish it, I'm recording that this video on April 9th. So if you go to your assignment page, you could see different due date. Always stick to the due date found in here. Okay, I'm going to start the recording right now. Have a great day, and see you in a Zoom meeting, or catch you in the next video. Have a great day.